Welcome to second day for the course IWCF well intervention level 4. Today, inshallah, we'll cover the second section, which is the completion equipment. I will share the presentation. So the first important thing we need to look at, which in page 87. Okay, it will be talking about the tubing. Tubing is the hardware to convey or transport the production from the bottom of the formation or the well up to the surface. The tubing is the greatest part in the completion component. Okay, isolate annulus from the tubing, so produce from inside the pipe. When I need to specify or make a specification for the tubing, so specify with the size. The size, when I said tubing 3.5, that means OD for the tubing is 3.5. Up to 5 inch, it is classified as tubing. From 5 or above, it is classified as casing string. Second thing is the thread type. We describe the thread type. It can be API thread like EUE, Patris, or LTC. This is connection for casing, Patris and long thread component, or premium like VAM, new VAM, top VAM, or Tenaris Blue. I can classify also tubing with the grade. Grade, you have 2-part letter here like K55. So 55, that means 55,000 is described the minimum tensile strength for the pipe. I can describe also like the component for the steel. It can be carbon steel or chromium or 9% or 15% to resist the corrosive fluid, or also corrosion and high water cut pressure. Weight described like 3.5 tubing 9.2. This is 9.2 pound per foot. I give you the relation between the ID and the OD. When the weight is increased, OD is constant, so the ID will be less. So this one 3.5, new VAM, L80 9.2. This is the OD, thread type, grade, and also this is the weight. Tubing length, there is 2 API tubing range in length. Range number 1 from 20 to 24. Range number 2 from 28 to 32 feet. The average length for the tubing about around 30 feet or maximum 10 meters. There is pop joint using for space out the string, available from 2 to 20 in 2-inch increment. This is for space out for depths for pucker, for example, at certain depths. We use at the top for the string some pop joint to space out. As we said, tubing connection, we have API thread. This rely on thread compound or the grease you install between the pin and box connection to make the effect seal, like STC, Patris, LTC, or EUE. This type for connections usually used while production in low pressure and oil well. Premium one, this is metal to metal seal. That means there is shoulder or space in the top or in the front for the thread, which have the same section inside the box to make metal to metal seal, like VAM, Hydril, or new VAM. That's why this is good for sealing. That's why it is used for especially gas or high pressure oil well. This is type for API EUE connection, offset connection, and this is the hydril. You have 2 seal area in the hydril tubing. This is the offset for external offset API EUE. There is no offset here. This is the offset area. And this is the API integral joint pin by box connection. This is the connection. This is the thread, and this is the box for coupling for the VAM tubing or casing. What is the purpose for the thread compound? In API and the premium, it is make lubrication when you install only in the pin connection. It make lubrication to help to make up the or break up the connection for the torque. Additionally, in API connection, it seals the voids between thread surface. So that's why the compound or thread compound is responsible for make seal and AOE connection, for example. The selection for tubing here, when you design for completion, there is some selection based on that one. Like there is some factors you need to check while designing the well. First one, what is the gross production rate you are going to produce from the well in the future? Types for well formation coming from the well, oil, gas, or water, contain any H2S or CO to select the suitable grade for the tubing. Formation properties, the maximum well depth you reach, downhole pressure and temperature effect on the elongation for and contraction for the pipe design, annulus differential pressure between tubing and annulus, any plan for well intervention operation like coiled tubing and wire line to select the minimum restriction or ID in the tubing, which maximum OD to pass for well intervention operation or tools, existing stock or the availability for the tubing in the warehouse or in the location. This is the completion equipment. Accessories from bottom to top. Here, this is a schematic for producing well from bottom perforation. Bottom for string will be above the perforation. Wire line entry guide in the end here. After that, there is in green here 2 landing nipple. Between is 1 perforated joint. Then this one is permanent pucker set below the above top perforation, and there is blast joint here, and there is retrievable pucker, sliding side door or SSD above the pucker retrievable, and some SPM side pocket mandrel for gas lifting operation, secondary source for artificial lift, and this one is landing nipple, flow coupling here with blue, and this is the subsurface safety valve and control line to subsurface safety valve in the top tubing, and after that in the top there is tubing hanger hang all the way for the string. Let's check in details. First one from the bottom, it will be wire line entry guide. From its name, it is designed to allow after the wire line or slick line coming out from the string to make some job below, to help this one to enter again the wire line tool inside the string bed. That's why the shape for wire line entry guide is different from normal connection for the pipe. So it can be designed in 2 shape or 2 design. First one is called mole show, 45-degree angle cut on one side, this one. And second one is bell guide, the shape for the bell. So this one incorporate 45 lead in taper. Both have this one, mole show is used in vertical well usually, and bell guide usually we prefer in highly deviated well. This is the two type, mole shoe and bill guide. This is the mole shoe at the bottom for seal assembly, using to sting inside top packer, and there is seal assembly here, section for seal assembly, packing element to seal the pipe one section inside the packer. After that, we'll talk about the landing nipple. The landing nipple has a profile from inside to accommodate or set the flow control device, retrievable flow control device, which is the plugs. The plugs is used as a barrier or isolation barrier inside the string. So short tubular, short section, pin and box connection, part from the compression string. It contains shoulder, three features, shoulder, polished pore area, and locking grooves or profile to accommodate the plugs inside. There is different type for landing nipple, and different numbers for landing nipple can be used inside the compression string. One is called X profile or R profile, and another one is called XN or no-go nipple or RN profile. This one is non-selective nipple, which is end with N, no-go or non-selective. This one use only, one nipple used in the bottom for the string. The XN usually, because there is, why no-go? Because there is small restriction in the bottom or in the top for the nipple. This indicates that where the plug is set inside, it does indicate when we tag the bottom for the no-go. And also the no-go has another job. If any tool has larger OD than the ID for the restriction and fall inside the pipe, it is prevent and hang in this area, prevent the tool to come and fall inside the well hole. This is non-selective nipple. Another type is selective nipple, which R or X nipple. According to the manufacturer for the nipple, like Halliburton or Schlumberger, each one has its profile from inside. So if you are going to use X nipple, you need to use X plug with the same manufacturer. Why? To sit or match inside its profile. Ported nipple, this one, it can be used optional. If you need to circulate, will open this port and you can circulate through. Okay. And last one is safety.
Ahmed, how can we open this port?
You drop, you pressures, you drop ball and you pressure up to open this port for circulation.
Okay, thank you.
Okay. Safety valve nipple, this is the top nipple where the wire line retrieval safety valve can be set inside. And this is the port here for the control line to the surface to control opening and closing the subsurface safety valve. So here, non-selective type, this one XN, smallest ID in the tubing string, bottom most nipple, only one installed in the tubing. Selective, like this one, it's full bore, several nipples for the same size installed in the string. For example, this nipple below the retrievable pucker, I can set plug to activate or set the top pucker. The above one, I can set nipple inside to pressure test the string integrity for the pipe while running hole. The below one to set the permanent pucker. So each nipple you install in the string depend on the design or the job you need the nipple for. Here, if you look here, this is selective landing nipple. This one is the nipple, and this one is the plug. It will sit inside the nipple. So if you look here, in the top section, there is key profile, which take the looking dogs or looking key to sit inside its place. After that, there is seal bore area here, where the packing element here or elastomer will seal inside. So the packing element which makes seal for the plug inside its profile. This is another figures for selective nipple. If you look here, this is the looking dogs set inside its profile in the nipple here. Packing element will be set in its place. That's why when you run with running tool for the plug, you sit inside its place and you look the plug inside its nipple. So you give indication you reach to the dogs will be compressed and set inside its place. So the packing element reach its place in the seal bore area. This one is no-go landing nipple, like XN or RN nipple. This one, the cross-section in the nipple, and this one is the plug. If you look here, this is the no-go area, restriction area inside the nipple. So here it is the dog recesses, or where the looking dogs sit inside this area, and the packing element or the V packing here seal, it is come in the seal bore area. By reaching to the no-go, the operator for the slick line indicates that the plug inside its profile. Again, this one is cross section for plug inside its profile. This is the looking dogs. Okay, and this
why it is called no-go? What does it mean? It's just name, or is there
no-go
something else?
because there is restriction here, small ID. That's why it is called no-go. There is a small or restriction in the top or the bottom according to the design. Some no-go landing nipple with top no-go section or bottom no-go section. That's why it's no-go. It's called no-go or XN. If you look here, you will find, for example, this is top no-go nipple. Inside there is plug. The plug, the dogs here inside its place, and this is the restriction or the minimum ID inside, and the packing element here inside its place. If you look to this cross section, you will find here the dogs, and this one is sealing, and that one is the no-go. It is bottom no-go, the restriction from the bottom for the nipple. That's why it's called no-go. The no-go shoulder or no-go area, this restriction, has two functions. The primary one is locate or guide that the lock mandrel or the plug is locked into landing nipple K profile. That means the plug inside its place when you set the plug inside the nipple. Secondary job to prevent flow control device of the same size as the no-go landing nipple falling out of the end of the tubing. If you have any parted accessories in the pipe has OD above or larger than the restriction area, it will drop and hang in this no-go section. Prevent the tool to come and drop inside the whirlpool to prevent the fishing operation. That's why it is normally run as a bottom landing nipple below the pucker in the tailpipe. That's why it is the last one, because if you are going to any tool drop, it will hang if the OD above or larger than the ID for restriction or no-go area. So this is the primary and secondary job or function for no-go restriction or no-go shoulder. This is the top no-go and this is bottom no-go section.
Remember in the previous slide we have a fish neck mentioned for no-go. What is the significance for that fish neck?
Fish neck, it will be in the top.
No, in the previous slide. In the previous slide, we have fish neck for no-go nipple.
This one? This fish neck,
Yeah.
the fishing neck is to retrieve the
Okay,
plug
okay.
from its
Plug,
profile.
plug. Okay, okay.
This is
Okay,
plugged
fine.
to
Sorry.
retrieve from its place, fishing neck.
Yeah, okay.
Was
Okay,
pulling
fine.
to. Okay.
Yeah, fine. Thank you.
After that, we'll go to talk about the subsurface safety valve, which we describe as emergency valve to shut off the flow for the well in case of emergency. If you have failure in the Christmas tree, if you have fire, if you have war or something like this, so it is prevent uncontrollable hydrocarbon flow possible caused by surface impact or explosion. So it is stop. That's why it's fail safe. That means when it is fail, it is go to save mode. That means when you cut the source for hydraulic pressure, opening the valve and drop to zero, it will close itself, preventing the flow from below of the production. This is the main objective for subsurface safety valve. Usually, subsurface safety valve is mandatory in most offshore rig and also in any wells near to population area or near to city or camp. And also according to the policy for the company. Set below crater depths and have hydraulic pressure through the control line to operate the subsurface safety valve from the surface. Usual setting depths for subsurface safety valve range from 3 feet, 300 feet to 500 feet from the surface. What is the type for subsurface safety valve?
Set below crater depth. What is the crater depth?
Crater depth,
And
that means any depths is have earthquake depths or unstable depths. I mean, so you need to set in depths is not affected by any surface impact or any earthquake or unstable area. This is mean crater depths.
Okay, and above CL hydraulic fluid hydrostatic.
And above there is control line contain hydraulic fluid oil to operate with the hydrostatic head from the surface to the subsurface valve to operate from the surface by hydraulic pump to operate open and close. When you apply pressure from the surface, the flubber for the subsurface valve will be open and kept open during production. If you release the pressure, the subsurface safety valve it will be closed automatically in safe way.
Okay, fine.
Okay. Subsurface safety valve types. There is two types for subsurface safety valve. One is surface control SC is referred to surface control subsurface safety valve. It is controlled from the surface with control line pressure. Open by pressure, release the pressure, will close by itself, fail safe. Another type is SSC, SSV, subsurface control, subsurface safety valve. That means the control for this type is depending on the condition for the well, the flow rate or the pressure drop or differential pressure across the valve. Most of the subsurface control, subsurface safety valve is wireline retrievable valve. It can be replaced by running the slick line to retrieve and replace the subsurface safety valve because this one is depending on the condition for the well. If the condition for the well is changing, that means we need to replace that one immediately. So it must be wireline retrievable safety valve. This surface control can be wireline safety valve or tubing retrievable safety valve. Tubing retrieval, that means we need to pull the tubing to replace the safety valve, subsurface safety valve. So subsurface safety, the closing mechanism is composed of ball
Yeah,
or
Emma?
flubber. Yeah.
Triple SP types. The second one is subsurface
Subsurface
controlled.
control. Subsurface
And then-
safety valve.
Okay.
Okay. This surface control, this is subsurface control. The control is from the down, from the condition for the hole. Okay. The closing mechanism here is composed of a ball or flubber under normal condition is kept open by a calibrated spring. You have calibration at the surface for pressure drop or delta B. You adjust at the surface and you run the valve. In normal condition, it will be open. If the delta B is changed, it will start to close itself. That's why it's controlled in subsurface. You don't have control line from the surface to control opening and the closing. That's why it's called subsurface control. Okay. You have two types here for the subsurface controlled. All the control for subsurface safety valve is by pressure. The pressure from the surface for control line or the pressure or differential pressure inside the well. Okay. There is two types for subsurface control. One is differential pressure or velocity operated, and second one is pressure operated or ambient pressure. This valve close when the differential pressure in the valve exceed certain or setting value you set in the surface due to the increase in the flow. At that moment, the valve flow tube, which you will see in the next page, move upward, overcoming the spring force and dragging the valve to the closed position. Normally, differential pressure in the surface is set and keep the valve in open position. When the differential pressure due to the drop in the flow it changed, so the force will start to overcome the dragging force of the valve to start the valve to close and close position. Another type is working on pressure operated or ambient. This valve has a pre-charged gas chamber. There is gas chamber have pressure at the surface, charged. Those pressure making the spring move to the closed position. If this pre-charged chamber pressure is drained, so the valve will be closed again. So we need to pull the valve by wire line and set the pre-charge value again and run with the valve again. The valve close when or any reason the pressure in the point become lower than the pre-charge value setting at the depth. So this type of surface we set the value according to the design for the flow for the well, differential pressure or ambient pressure with the pre-charge chamber for gas, especially nitrogen. When this condition is changing, that means the valve is closed by itself without control from my side. So I need to run the slick line to retrieve this types for subsurface safety valve and charge or check the value for pressure differential and run back again. So this usually subsurface control is not common type now and during the operation because it's controlled from the downhole. But the best one now is the most common usable is the surface control from the control line at the surface, which is easy to operate. This is the differential subsurface safety valve. And this one is pressure operated charge chamber for nitrogen or gas. This is pressure operated surface controlled subsurface safety valve. There is two mechanisms or two retrieve for the surface control subsurface safety valve. The subsurface control usually wireline retrievable. But surface control, subsurface safety valve has two mechanisms to retrieve. Wireline retrieval safety valve, which sit inside the safety valve landing nipple on the surface, below the surface. And another type is called tubing retrievable safety valve, TRSV. That means this is part from the tubing. If you have any failure in the subsurface safety valve, you need to decomplete the well. You need to kill the well and pull the string to the depths for the safety valve, and you replace it with new one. The easy one for sure is the wireline retrievable safety valve to exchange or replace by slick line. The closing mechanism for the valve, it can be ball type mechanism or flubber type mechanism. Usually the easy one is the flubber type. Flubber, open and close with the pressure, which is the easy one, or the most common use nowadays is the flubber type. Let's have a look on the tubing retrievable and wire run retrievable safety valve. If you look here, this is safety valve landing nipple, run part from the tubing or compression string. There is profile here for seal pour and the profile for the dogs or looking mandrill. And this is the port for control line port. After you run the compression string to its depths, you will take this wire line safety valve and you start to run this one with the slick line. Wire line safety valve start to come inside its place like this figure. So the dogs come inside its profile, and the flubber here or seal bore come its place, and there is a spring here. When you inject in the control line the pressure, the piston will push the spring, push the flow tube. The flow tube will open the flubber of the valve. When you release the pressure, so the spring will push up the piston. So the flow tube, this one, the flow tube, the brown one, will come up, so the flubber will close itself. Okay, this is wire line retrievable safety valve set inside its nipple. Here the control line between two packing elements to inject pressure to operate the wire line retrievable safety valve. While running in hole, usually wire line safety valve must be run inside the well while running with slick line in open position. So you will able to run inside the hole, full hole.
Ahmed, what is SVLN stands for?
Safety valve landing nipple.
Oh, okay, thank you.
Okay. So wire line retrieval safety valve, when you run in hole, you need to run in open position. Okay. This one must be open, the flubber, so you'll be able to run inside the hole. How we can control this one in open position? You have something called brong. Brong, this is something like bar. You sit in the surface with a slick line to keep this flubber in open position. Okay, and you run inside the well. After you sit in its place, you run slick line with pulling tool, so you retrieve the prong from inside the wire line safety valve, and you close it again, and you start to control from the surface by control line. When you pull the wire line safety valve, you need to close first, and after that you pull out from the hole. This is the most procedure for running in open position and pulling in closed position. The another type is tubing retrievable safety valve. This is one part, one section connected from top and bottom to the string or the compression string. That's why it's called tubing retrievable safety valve. It is connected with the same component, piston, flow tube and the spring and the flubber. It is run also in open position, part from string, so we can have control line connected from the surface. You can pressure up control line at the surface to keep this tubing retrieval safety valve in open position while running in hole. This is the first way to keep in open position. And also there is a second method to keep in open position while running in hole, the tubing completion, by installing something called straddle, also like bar or slick line. We kept this one in open position. After that, you reach to the setting depths, you retrieve by a slick line. If you look in the tubing retrieval safety valve, you will find here in the top there is landing nipple profile here. From this point, you can set any plug above the tubing retrieval safety valve. This is landing profile, and here in the top there is lockout mechanism. If you have failure in the tubing retrieval safety valve, you have two options. First option is to kill the well and decomplete and pulling out compression string to change that one. Or there is another option which is expensive little bit, to convert the tubing retrieval safety valve to wireline retrievable safety valve. How it's come? You will run with a slick line to lock this flubber in open position. You're jarring down many times and lockout mechanism here up on top. So you will keep permanent this flubber in open position. After that, you install in the profile nipple in the top wireline retrievable safety valve. Connected, we perforate first here hole to connect the control line, the same control line to this profile. So we convert the tubing retrievable safety valve to wireline retrievable safety valve. This can be happen usually in subsea well, completion for subsea, where the completion or decomplete the well and kill the well and getting this out from the hole is very expensive compared with converting the tubing retrievable safety valve to wireline retrievable safety valve to produce again from the well or completion. Here, how to insert wireline safety valve in failed tubing retrievable safety valve. If you look here, from tubing retrievable to insert wireline retrievable. Here, there is landing nipple, as we said, for insert wireline retrievable safety valve or straddle. Okay, there is control line here, and piston, flow tube, spring. This is the valve now is failed. So we need to convert to wireline. So first, you will make hydraulic communication with control line between the two vacuum. Once the lock mandrel, and after that we set the nipple and lower area for the surface line can be seal and mount. Look here, you start to insert wire line and look in the nipple profile, okay, connected here with the control line after we make port. Then before that one, you make this one and look permanent lock position, open position, and this one is the straddle tool we said before. We set inside the profile to keep the flapper open while running inside the well. This is the way how to convert wireline. It is available, but it's cost a little bit. But comparing with subsea well, to pull the string to change, it will be more cost. That's why this is optional to do. Okay. Understand?
Yes, Mr. Ahmed.
Okay, thank you.
All right, we can stop. I think now is 1:30, 1:35. We shall stop for lunch break, half hour, and after that you can continue.